This is SpaceTime, Series 20, Episode 13, for broadcast on the 17th of February 2017. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, a new date for the solar system's early evolution, a supermassive black hole setting a new feeding record, and India sets a new world record launching 104 satellites at once. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that our solar system and its major planets were all formed within the first 4 million years of the Sun's birth. The findings, reported in the journal Science, place the most precise date yet on the solar system's early evolution and the length of time the system's protoplanetary disk was present. About 4.6 billion years ago, an enormous molecular cloud of hydrogen gas and dust collapsed under its own mass, possibly triggered by shock waves from a nearby supernova. Dozens, maybe even hundreds of protostars began to grow deep inside the dark recesses of this giant molecular cloud. As they formed, the angular momentum of the contracting molecular gas and dust caused the regions around each of these forming protostars to begin spinning, producing a series of flattened protoplanetary disks. Eventually, when the temperatures and pressures got high enough to ignite nuclear fusion at the center of each of these disks, a star was born and began to shine. One of these protostars was our Sun. The small amount of material left over in the protoplanetary disk after the Sun's formation continued to condense and eventually form the planets and other bodies which make up the Sun's solar system. Estimating the lifetime of this protoplanetary disk or solar nebula provides details about a key stage during which much of the solar system took shape. The study's lead author, Benjamin Weiss from the Massachusetts Institute of Technology, MIT, says while the planets continue to evolve after that, the large-scale structure of the solar system was essentially established within that first 4 million years. This new time estimate suggests that the gas giants Jupiter and Saturn must have formed within that first 4 million years of the solar system's formation. Furthermore, they must have completed gas-driven planetary migration of their original orbital positions by this time. Weiss and colleagues reached their conclusions by studying the magnetic orientations of pristine samples of ancient meteorites that formed 4.653 billion years ago. It was this which allowed them to determine that the solar nebula probably lasted around 3 to 4 million years. That's a far more precise figure than previous estimates, which placed the solar nebula's lifetime at somewhere between 1 and 10 million years. The authors came to their conclusion after carefully analysing angrites, which are some of the oldest and most pristine of planetary rocks. Angrites are igneous rocks, many of which are thought to have erupted onto the surfaces of asteroids very early in the solar system's history. They then cooled quickly, freezing into place their original properties, including their composition and paleomagnetic signals. Because of this, scientists view angrites as exceptional recorders of the early solar system. They're even more special because the rocks contain high amounts of uranium, which can in turn be used to precisely determine their age. In fact, Weiss describes angrites as being especially spectacular. Many of them look like lavas erupting on Hawaii today, but they actually cooled on some of the solar system's earliest planetesimals. Weiss and colleagues analysed 4 angrites that fell to Earth at different places and times. One of them fell in Argentina and was discovered by a farm worker tilling his field. To him, it looked like an ancient Indian artifact or bowl, and the landowner kept it in his house for about 20 years until he finally decided to have it analysed. It was only then they discovered that it was actually an extremely rare type of meteorite. The other 3 meteorites were discovered in Brazil, Antarctica, and the Sahara Desert. All 4 meteorites were remarkably well preserved, having undergone no additional heating or major compositional changes since their original formation. The study's authors obtained samples from all 4 meteorites. By measuring the ratio of uranium to lead in each sample, Uranium eventually radioactively decays into lead. Previous studies had already determined that the three oldest formed around 4.653 billion years ago. The researchers then measured the rock's remnant magnetism using a precision magnetometer at the MIT Paleomagnetism Laboratory. V says electrons are a little like tiny compass needles, and if you align a bunch of them in a rock, that rock becomes magnetized. Once they're aligned, which can happen when a rock cools in the presence of a magnetic field, they stay that way, and scientists can use them as records of ancient magnetic fields. But when they placed the angrites in the magnetometer, the authors observed very little remnant magnetism, and that indicates there was very little magnetic field present when the angrites formed. The team then tried to reconstruct the magnetic field which would have produced the rock's alignments, or lack thereof. To do so, they heated up samples and then cooled them down again in a laboratory-controlled magnetic field in order to try to reproduce what they saw in the meteorite samples. Specifically, the team found that the angrite's remnant magnetism could have only been produced by an extremely weak magnetic field of no more than 0.6 microtesla some 4.653 billion years ago, and that's about 4 million years after the start of the solar system. Back in 2014, Visa's group analysed other ancient meteorite samples that formed within the solar system's first 2 to 3 million years. Back then they found evidence of a magnetic field that was 10 to 100 times stronger, in other words about 5 to 50 microtesla. V says once the magnetic field drops by a factor of 10 to 100 in the inner solar system, which is what his team have now shown, then the solar nebula should disappear quickly, within about 100,000 years. This new estimate's far more precise than previous estimates, which were all based on the observations of faraway stars. Since the solar nebula's lifetime critically affects the final positions of both Jupiter and Saturn, it therefore also affects the later formation of the Earth, as well as the formation of the other terrestrial planets Mars, Venus and Mercury. Now that the authors have a better idea of exactly how long the solar nebula persisted, they can also narrow in on how the giant planets Jupiter and Saturn formed. The giant planets are mostly made of gas and ice, and there are two prevailing hypotheses for how this material all came together to form planets. One idea suggested the giant planets all formed from the gravitational collapse of condensing gas, just like the Sun did. But the other suggested they arose in a two-stage process called core accretion, in which small bits of material smashed together to make gradually larger and larger bits which fused together to eventually form the bigger, rocky, icy bodies. Once these bodies were massive enough, their gravitational force would have attracted huge amounts of gas, ultimately forming a gas giant. According to previous predictions, giant planets that form through the gravitational collapse of gas should complete their general formation within about 100,000 years. By contrast, core accretion is typically thought to take much longer, on the order of 1 to several million years. V says if the solar nebula was around for the first 4 million years of the solar system's formation, this would give support for the core accretion scenario, which is generally favoured among scientists. So what it means is the gas giants must have formed by about 4 million years after the formation of the solar system. First there was Jupiter, which began migrating inwards, gathering more and more material. In Jupiter's wake, Saturn began forming, and once it was massive enough, it began pulling Jupiter back out again, eventually to its current orbital distance from the Sun. The planetary migration of both Jupiter and Saturn would have caused massive gravitational perturbations and tidal forces, flinging material and planets all over the place. It was during this time that the ice giants Uranus and Neptune were both pushed further outwards, and possibly even swapped places, while a potential third ice giant was either flung out of the solar system altogether, becoming a rogue planet in interstellar space, or it was flung into the outer solar system, deep in the Kuiper belt beyond Neptune, where it now resides as the long-sought-after Planet 9. While all this was happening in the outer solar system, Jupiter's migration also gave the inner solar system its present appearance, with the two Earth-sized terrestrial worlds, Venus and Earth, bordered by two far smaller planets in the guise of Mercury and Mars. V says the planets were moving all over the place, in and out over large distances, and all this motion is thought to have been driven by those gravitational forces during that first 4 million years. I'm Stuart Gary. You're listening to SpaceTime. A giant black hole has ripped apart a star and gorged on its remains for over a decade, more than 10 times longer than any previously observed episode of stellar death by black hole. The findings, reported in the journal Nature Astronomy, were made using a trio of Earth-orbiting space telescopes, including NASA's Chandra X-ray Observatory and Swift Gamma-ray space telescopes and the European Space Agency's XMM Newton X-ray telescope. The process is known as the tidal disruption event. It occurs when tidal forces due to the intense gravity of the black hole destroys an object such as a star that happens to wander too close. During a tidal disruption event, some of the stellar debris is flung outwards at high speeds, but the majority will fall in towards the black hole. As it travels inwards, it forms an accretion disk just beyond the black hole's event horizon, the point of no return, beyond which material falls forever into the singularity. The material on the accretion disk is torn, crushed, and ripped apart at the subatomic level. In the process, it's heated to millions of degrees through friction, generating powerful X-ray flares. While dozens of tidal disruption events have been detected since the 1990s, none have remained this bright for this long. The extraordinarily long, bright phase of this event, spanning over 10 years, means that among observed tidal disruption events, this one was a doozy, the most massive star ever seen being torn apart by one of these events. The event itself wasn't detected in Chandra observations on April 2, 2005. But it was detected just a few months later in an XMM Newton observation on July 23, 2005. It then reached its crescendo in brightness in a Chandra observation taken on June 5, 2008. These observations show the source became at least 100 times brighter in X-rays as the star was completely torn apart. The X-ray source containing the black hole, known by its abbreviated name of XJ1500 plus 0154, is located in a small galaxy about 1.8 billion light-years away. Since the initial observations, Chandra, Swift and XMM Newton have observed the object on numerous occasions. The sharp X-ray vision of the Chandra data shows that XJ1500 plus 0154 is located at the centre of its host galaxy, the expected location of a supermassive black hole. The X-ray data also indicates that the radiation from material surrounding this black hole has consistently surpassed the so-called Eddington limit, defined by the balance between the outward pressure of radiation from the hot gas and the inward pull of gravity from the black hole itself. One of the study's authors, James Goloshan from the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts, says this object's been growing rapidly for most of the time that it's been observed. This tells astronomers something unusual, like a star at least twice as massive as our Sun is being destroyed by a black hole. The conclusion that supermassive black holes can grow from tidal disruption events, and perhaps other means, at rates far above those corresponding to the Eddington limit, has important implications. You see, such rapid growth may well help explain how supermassive black holes were able to reach masses 1 billion times higher than that of the Sun at a time when the universe was still only about 1 billion years old. Put simply, this event shows that supermassive black holes really can grow at extraordinarily high rates. As a result, it helps scientists better understand how precocious black holes came into being. Based on the modelling, this black hole's feeding supply should be significantly reduced within the next decade. And that should result in XJ 1500 plus 1504 fading in X-ray brightness over the next few years. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
It's been devouring a star that has fallen into it.
Oh.
So it's devouring a star. This is a process that's been going for 11 years. What's happening, and let me put it in the terms that we astronomers think in, which is all about the way you observe it. What you've got is optical, that's to say visible light observations of this galaxy, which is very distant. It just looks like a blob in Hubble telescope images. But when you observe it with Hubble's equivalent in the X-ray region of the spectrum, and this is a spacecraft called Chandra, it's a sort of relative of Hubble. It's part of the same sequence of great observatories. And Chandra is a spacecraft that doesn't look for visible light. It looks for X-rays. Not to see through things, but because we know that X-rays are emitted when you've got gases that are heated to extremely high temperatures. And what's happened over the last 10 years, this little galaxy has been growing very, very bright in X-rays. And its radiation has not just kind of gone up, it's gone up and fluctuated a bit. And the interpretation of that we have from the X-ray astronomers is that what we're seeing is the effect of a star being decimated by the gravity of the black hole. So that this star has wandered close to the black hole. It's been grabbed by the black hole's gravity and thrown into something we call the accretion disk. The accretion disk is a disk of material swirling around the black hole, which is eventually being swallowed up by the black hole. So that disk of material is actually rotating at very high speed. When a star falls into it, first of all, the star is basically dismembered by the gravity of the black hole. But that material that's fallen into the accretion disk is churned up by the accretion disk and gets to very high temperatures. And so then you start getting the X-ray emission from this object. And it's the X-rays that have really betrayed what's actually going on in the vicinity of this black hole as it devours this star and takes 11 years to do it. It's not a quick meal by any means.
So this is more or less like pulling the plug on your sink. This is what's happening.
It's exactly right, yeah. So that, if you take your plug out and the water goes down the plug hole, that's more or less what's happening to the accretion disk of the black hole. It's being sucked in. It's always a mistake to think of black holes wandering through space and gobbling up everything in their path. They tend to be very stable and they more or less stay put. But when you've got something that is big and is basically being absorbed by the black hole, there would certainly be quakes in the black hole's motion. It's this star that's done that. We've seen it eating the star up and releasing the X-ray radiation.
Okay. I can't even begin to comprehend the power of a black hole. I mean, if a black hole can dismantle a star, it's so much more powerful than the imagination could probably piece together. It's incredible, isn't it?
Absolutely. And it defies your imagination anyway, because by definition, a black hole is a point in space where the density is infinite. So something with infinite density boggles the imagination. And, when you think of this thing's probably got a mass of maybe 1 million or 2 million times the mass of the sun. So it's a massive object. And a little star like that coming near it, even though it's actually a star twice as big as the sun, is still, it's still taking a while to be gobbled up.
Yeah. There's so many theories about black holes and even as far as disrupting time. I mean, what do we actually know versus what's theory? That's the weird part for me.
That's right. So a black hole, because a black hole's got such a strong gravitational influence, gravity doesn't just distort the space around it, it also distorts time. So that if you fell into a black hole and we watched you, basically there would be a point at which it appeared that time had stopped for you, that you'd be kind of splattered on the edge of the black hole, even though the real Andrew Dunkley has gone through that limit and is being spaghettified, it's being turned into spaghetti by the gravitational forces of the black hole. Nevertheless, it would look to us as though time had stopped for you. And that's because of the gravitational time dilation, as it's called.
Okay, so that's what happens. And we do have a black hole at the centre of our own
that's right, yes,
galaxy, don't we?
One of the best studied black holes is at the centre of our galaxy. It's in the constellation of Sagittarius here in Australia. It passes directly over our heads once a day and is 26,000 light years away and is of no threat whatsoever to the Earth.
Yeah, that's close enough.
Yeah.
Don't get any closer. Just stay where you are. Nothing happening here. We're all fine.
Just stay in the background.
Yes, that's exactly right. Okay, so this poor old star's being devoured over, well, in universal terms, 11 years is like a flash.
It is.
And this is probably happening all over the place.
It is, although this the scientists who have been working on this say that it's the longest known tidal disruption event, which is a posh name for a star being devoured. It's the longest known in our experience. We haven't ever measured one longer.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program Space Nuts. And this is SpaceTime with me, Stuart Gary. Okay, time to take a quick break from the show and talk about one of our sponsors. There are many times when you can't hold a book, but you can listen to one, such as when you're commuting, when you're at the gym, jogging, or walking the dog. And that's when I listen to Audible. It's my audio bookstore. And I love the idea of someone reading to me. And no one offers a greater selection than Audible. In fact, they've got something like 180,000 titles plus to choose from. Audible's great if, like me, you have an unquenchable thirst for knowledge. Audible means you can learn so much. And right now, Audible has a special deal for SpaceTime listeners. Audible's offering a free audiobook download with a free 30-day trial to give you the opportunity to check out their service. And they've got so many great books to choose from. All the bestsellers, the classics, science fiction, science fact, history, biography, whatever, often from the people who actually wrote them. How about Born to Run by Bruce Springsteen, narrated by Bruce Springsteen? Or The Life of Keith Richards, narrated by Johnny Depp, Joe Hurley and Keith Richards himself. No matter what your taste, there are over 180,000 titles to choose from. To download your free audiobook today, go to audibletrial.com/spacetime. That's audibletrial.com/spacetime for your free audiobook. Or just click on the link at spacetimewithstuartgary.com. And now, back to our show. India's first launch for 2017 has set a new record, carrying some 104 small satellites into orbit on a single rocket. The Indian Space Research Organisation's PSLV, or Polar Satellite Launch Vehicle, blasted off from the Satish Dhawan Space Centre on the coast of the Bay of Bengal. The 44-metre-tall rocket's payload included 3 small conventional satellites as well as 101 tiny CubeSats. The 4-stage PSLV was in its XL configuration. It included 6 strap-on boosters, 4 of which were ground-lit, igniting at launch together with the core stage's main solid-fueled rocket engine. The remaining 2 strap-ons were air-lit, igniting 25 seconds after launch.
PS2 VSPPs are opened. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, 2, 3, 4, 5, 6 of normal, 7, 8, 9, plus 10 seconds.
A perfect liftoff, as usual for PSLV, and you can see in all glory, PSLV negotiating the dense atmosphere, all the strap-ons firing well.
Plus 25 seconds.
गर्जना से आकाश के संग्राम में जीता
Plus 30 seconds.
विश्व की सारी मानवता के नाम भारत का ये शांति
Plus 25 seconds.
The ground-lit strap-ons were depleted and jettisoned a minute and 10 seconds after launch, followed 22 seconds later by their air-lit counterparts. A minute and 51 seconds after launch, the PSLV's first stage was jettisoned. The second stage then ignited its hydrazine and nitrogen tetroxide liquid-fueled Vickers engine for a 2.5-minute burn, after which the third stage solid-fueled rocket motor was ignited for a 2-minute burn, followed by a coasting phase. Third stage separation finally occurred just over 8 minutes after launch, with the fourth stage then igniting its liquid-fueled engine for an 8.5-minute burn to take the payload into orbit. India's Cartosat 2D was the first of the major payloads to be deployed. The 714-kilogram satellite is the fourth in a series of high-resolution Earth-orbiting spacecraft developed by India. The satellite will operate for 5 years, monitoring coastlines, urban growth, rural infrastructure and water usage. 10 seconds after the release of the Cartosat 2D, the INA 1A and 1B technology demonstrator spacecraft were also released. They feature a new smaller satellite bus designed to attract universities and small business payloads. Then came the deployment of the 101 CubeSats. These included 88 Planet Company CubeSats, which will join 100 already in polar orbit, forming a massive private satellite constellation. The 4.7-kilogram shoebox-sized satellites are each equipped with tiny cameras. They're designed to image the entire planet every day, monitoring natural resources and agricultural yields, and providing data to disaster relief responders. A further 8 CubeSats will track global shipping movements and monitor weather conditions for the American company Spire Global Incorporated. Their deployment takes Spire's satellite fleet to some 29 CubeSats. The most sophisticated of the CubeSats deployed was the milk carton-sized 5-kilogram Israeli BugSat scientific satellite. BugSat's designed to specifically study weather phenomena from orbit, monitoring carbon dioxide levels, ground moisture variations, and the worsening problem of human-induced climate change. The remaining 4 CubeSats deployed were carrying a range of scientific and telecommunications demonstrator technologies for the Netherlands, Switzerland, Kazakhstan and the United Arab Emirates. This launch was the 38th successful flight for the Indian space industry. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is Spacetime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for Spacetime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.